Here is the next example. F of s equal to 6s square plus 8s plus 3 divided by s times s square plus 2s plus 5. So the order of the denominator is going to be 3. So here we have to have 3 constants. Okay, we have to have the 3 terms, but I cannot write the third term because this s square plus 2s plus 5, it's not a perfect square. Okay, so I have to keep this s square plus 2s plus 5 as a single term. So here I have 2 poles, so I will end up with 2 constants bs plus c. Now here I can find a by using direct substitution method. So the whole function except denominator of s, so 6s square plus 8s plus 3 divided by s square plus 2s plus 5, substitute s equal to 0. I end up finding a equal to 3 by 5. Now we can, as I mentioned, we can find only a value by using substitution method. B and c we cannot do that. So bc, to find bc, same method, I'm going to do the LCM. So LCM for this is s times s square plus 2s plus 5, a multiplied by this, and bs plus c is multiplied by this. So a times s square plus 2s plus 5 plus bs plus c times s. Okay, so the denominators are same. I mean, the given function is here. So given function has denominator s times s square plus 2s plus 5. Here also s square plus 2s plus 5 times s. So the numerators must be equal. So 6s square plus 8s plus 3 equal to as square plus 2s plus 5 plus bs plus c times s. So if you make s square terms equal, I have 6 in the left hand side, a plus b on the right hand side. So I already know a value, so I end up finding b equal to 27 by 5. Same thing if I substitute or if I equate s values, s coefficients. Here I have s on the left hand side, 2a plus c on the left hand side. So I found c value as 34 by 5. So I end up f of s equal to 3 by 5 over s plus 27 by 5s plus 34 by 5 s square plus 2s plus 5. So by using Laplace table, we can easily find this value. Finding this value, we need to manipulate a little bit. So what I'm going to do here, this term, I'm going to separate this 34 by 5 as 27 by 5 plus 7 by 5. Okay. Why am I doing that? So that I can take out this 27 by 5 coefficient of this s. At the same time, the denominator s square plus 2s plus 5, I can write this as s plus 1 whole square plus 2 square. Okay. Now here I separated the terms. I took out 27 by 5, so I'll end up with s plus 1 over s plus 1 square plus 2 square. And here 7 by 5 over s plus 1 square plus 2 square. Now, if you look at here, Laplace transformation of e to the power of at cos bt equal to s minus a over s minus a square plus b square. So what is a here? I mean, in my case, I have minus 1. Okay, so that's the reason. So a here is minus 1. What is b value? 2. Okay, b value is 2. That's a, that's b. That's from the Laplace transform table which I provided on the blackboard. That number, I think you're going to use 19 and 20. This is 20. And for the next one, b over s minus a square plus b square. Since I don't have b here, so I'm going to divide and multiply by 2. So I will end up with 7 by 10 as a constant. And so I can write this as 2 by s plus 1 square plus 2 square. So 7 by 10 by, now this I can write this as I mentioned, 7 by 10 by 2 over s plus 1 square plus 2 square. Okay, so this is exactly Laplace transformation of e to the power of at sin bt. So here a is also minus 1, b is 2. Okay, so 7 by 10 e to the power of minus 2 minus t sine 2t. Okay, this is the function in time domain. So by using inverse Laplace transformation, we can transfer S domain function into time domain function. Okay, here is the next example. So in this example, I have, it's a second order system. So I have two poles, but at the same time, numerator also has two zeros. Okay, so the order of the numerator and order of the denominator is same. Whenever we are doing partial fraction, okay, make sure that the numerator order must be at least less than the denominator, one time less than the denominator, at least one. If they're equal, we cannot do the partial fraction. So what I'm going to do, I'm going to do the long division. So I'm going to divide 6s squared plus 8s plus 3 divided by s squared plus 2s plus 5. So if I multiply this with 6x squared plus 12s plus 30, I mean 6s squared, 2s plus times 6, 12s. Don't confuse, my s look like 5. Okay, 6s squared plus 12s plus 30. So I'll end up with minus 4s minus 27. So I can write this function as 6 minus 4s plus 27 divided by s squared plus 2s plus 5. Okay, so 6 minus 4s plus 27 by s squared plus 2s plus 5. Now, as I mentioned, I need to manipulate this a little bit to transform into the time domain by using that table. So what I did, I separated 4 plus 23 and I took out 4, so 4 times s plus 1 over s plus 1 square plus 2 square. Now this 23, I'm going to multiply and divide 2 by 2. So 2 over s plus 1 square plus 2 square. So I end up with 6 minus, okay, 4 e to the power of minus t. I mean, by using the table, I just wrote it down here. Okay, so e to the power of at cos bt equal to s minus a over s minus a square plus b square. So 4 times e to the power of minus t cos 2t, and this is 23 by 2 e to the power of minus t sin 2t. And I mean, if you have constant, it's not good idea to leave it as it is. I mean, since it's a time domain function or time dependent function, I'm going to multiply that with u of t. Okay, thank you. This is the fourth category. So in the inverse Laplace transformation, we have 4 types. One is one is individual poles. Individual poles, we can solve them by using substitution method. Second one is repeated poles. If you have repeated poles, then you have to do the LCM method. The third one is if it's not perfect square. Okay, if the poles are not perfect square, complex poles, that's called complex poles. If poles are complex poles, then you're going to do it as BS plus C. That's the third category. Fourth one is if you have number of poles equal to number of zeros, then make sure that you do the long division, and then make sure that your number of poles always at least number of poles are more than the number of zeros, at least 1. Okay, so I did the long division. After long division, solve the transfer function and then convert it into time domain. With this, I'm done with this inverse Laplace transformation. I might be able to post 1 or 2 more examples, but based on the time, I think this is good enough. Look into this. You should be able to solve the homework. If you have any questions, let me know. Thank you.